A body of weight 6 Newton rests on a plane inclined at 30 degrees to horizontal. A. What force keeps it from sliding down the plane? B. What is the coefficient of friction? This question is from friction. You know, friction opposes motion. In fact, this friction has many benefits in our life. It is because of this friction we can walk comfortably. Okay, think of a slippery place, a place that is slippery. Can you see that if you try to walk in a place that is slippery, you cannot walk comfortably because the friction there is not much. So if you try to move, the place will slide you, leading to fall. You get? So it is this friction that opposes motion. If you try to walk, the friction will oppose motion. Due to this opposing of motion, the two layers, that is the surface where you match your leg and the surface of your leg, there will be an opposition, and this opposition causes grip. It's because of this opposition that will make these two surfaces to be rough, thereby causing grip. Therefore, you can now grip the soil for you to walk comfortably. But if the place is slippery, there is no much grip because the place is slippery, then it will slide. Okay, think of tire of a car. You see how they put rough on a tire of a car. This is to create friction between the tire of a car and the road it moves, thereby creating a friction so that it can now grip the soil in order to move. If not, it will be slippery. So this friction is very, very important. The question on board is from friction, and it has formula for us to calculate it. Now, under normal circumstances, friction, which is F, is equals to mu R. Friction is equals to coefficient of friction multiplied by the normal reaction. This F equals to mu times R. F represents our frictional force. R represents normal because every action there is equal and opposite reaction. So R represents reaction. Then this mu is constant, called coefficient of friction. In a plane horizontal, we make use of this formula to calculate friction or calculate any one of it. But if it's an inclined plane, just like this question is an inclined plane, look at it. It's an inclined plane. This is an object lying on this inclined plane, and the inclined plane makes 30 degrees with the normal ground, with the horizontal, okay, makes 30 degrees. So this is an incline. This body now, if there is no friction, this body now, this an object tries to come down as a result of gravity. Normally, if there is no friction at all, the place is slippery, this body will start sliding down as a result of gravity, because gravity will try to push it down. But if there is enough friction, the friction will oppose this gravitational motion. It will oppose it, thereby holding it. So the question now says, what's this body now, what force will keep it from sliding down? What force will keep this object now from sliding down? So the force that will keep it from sliding down is frictional force, because frictional force opposes motion. So the force that will keep it from sliding down is frictional force. Now, so then if you want to calculate for the frictional force, this is the formula we use. But for inclined plane, as a result of this angle, we will now calculate frictional force to be W sine theta. Sine theta comes in as a result of inclined plane. So we can also calculate F to be equals to weight of this object sine theta. And under normal circumstances, normal reaction is equals to weight of the object. Under normal circumstances, under plane surface without inclining, R is equals to weight of the object. That is, normal reaction is equals to weight of the object. But if the body is inclined, we can calculate R to be equals to weight of the object cos theta. So we can get R with this formula and get F with this formula. They also say we should calculate mu, the constant of friction, that's coefficient of friction. Calculating for the coefficient of friction, F is equals coefficient of friction times normal reaction. But since we don't have coefficient of friction, we need to calculate for it. How can we calculate for it? We can now use coefficient of friction is equals to F all over R. We can use this formula to calculate it, which is equals to F. We can calculate F as W sine theta. And we can calculate this one as W cos theta. W represents the weight of the object. W represents the weight of the object. This thing now can be equals to tan theta. Because W cancel W, which is the weight of the object, we now have only sine theta over cos theta, and sine theta over cos theta is equals to tan theta. In our mathematics, I will still treat triangle to clarify you. I will still treat mathematics in triangle to clarify you this. Okay, now, so we have theta represent the angle. Theta represent the angle. We have 30 here. We now have, now what we have is now mu. That is coefficient of friction equals to tan theta, which is tan 30 degrees. When we work with our calculator, tan 30 degree to be 0.58 approximately. Now that is the B part of the question. We have succeeded in calculating it. Now let us now calculate for the frictional force. Now calculating for the frictional force is equals to mu times R, and the frictional force is equals to, that is, mu is coefficient of friction, R is the normal reaction of the body, and normal reaction of body is equals to the weight of the object. Okay, so we have calculated for mu, which is 0.58 times normal reaction. The normal reaction is equal to the weight of the object. And from the question, we have weight of the object to be 6 Newton. We have weight of the object to be 6 Newton. Now replacing R and fixes. When we multiply out, we now have 3.46 Newton answer. So thank you for watching. Please subscribe to my YouTube channel. Okay, thanks so much.